Okay, we've got Markov Chains Part 2. So we've got a Markov chain has the given transition matrix, and it's a 3x3 this time instead of a 2x2, which is fine. It can be any square matrix. It will have to be square, and we're given an initial state. So this is like the Trump-Clinton starting at 0.1, 0.9. And so these are chains because if this is our x, this thing here, and this is our m, after one stage we've got mx, and then we've got m times x, and then m times x in the first stage, second stage, or first week, second week, whatever stage you're using. Alright, so first off, find the value of x. Okay, if you recall from earlier, each of these columns has to add to 1. So that's pretty easy. X has to be 0.1. So to find the state after 2 stages, all you need to do is put into your calculator. You'll put these matrices in, and after 2 stages we will have squared this matrix and squared it and times it by this. So let me quickly pause and get my calculator out and do this. Okay, so on my calculator I got 0.3125, 0.3625, and 0.325. I think. Anyway, so that's that first question done. Okay, the next example is so from your textbook. Okay, if it's raining on a particular day, it's going to rain the very next day with a probability of 60%. If it's not raining on a particular day, the chance of rain the next day is 50%. So we have to make a transition matrix, and just remember you have across the top, so we've got, started off, we've got rain and no rain, rain and no rain. And remember, this is from, or before, and to. Okay, so I would suggest you pause the video for a minute and try to figure out on your own what numbers go in here. Okay, so you paused, we're back, now let's do it. So let's see, what does it say? From, if it's raining on a particular day, so that's the from day is rain, and it will rain the next day. So from rain to rain is 0.6. The column has to add up to 1, so the next one has to be 0.4. Okay, from not raining, the next line means from not raining to rain. So from not raining to rain is this top one here. So that's 0.5 and that is 0.5. So that is our transition matrix. Okay, probability of rain on Friday if it rained on Tuesday. Okay, so Tuesday is our initial state. Okay, so this was the answer to A. Now B. Tuesday, we've got to put 2 numbers in here. Okay, so what is, it's definitely raining on Tuesday, so what's the probability of it's raining on Tuesday? 100%. Okay, because these have to match these columns here, the rain and no rain. So rain, 100%, no rain, 0%. And 3 days later, so we've got to times by our transition matrix 3 times. So Friday is going to be 0.6, 0.5, 0.4, 0.5 to the power of 3 times 1, 0. And let me pause and do that one in the calculator. Well, I was too lazy to do it in the calculator. I just copied it out of the book. 0.556.444. So that is That's what we get on Friday. So has that answered our question? Well, not exactly, because it says find the probability of rain on Friday. So the probability of rain Friday, of course, is the first number there, 0.556. Okay. Okay, the last question. In the long term, what percent of days does it rain? In that first example, we did it all mathematically. I'm just going to do what they've done in the book. And they've just put a big number in for like the number of days. So, for example, they put 50. So 50 days later, everything should have leveled out, and they get this answer, which is almost exactly the same as the previous answer. So the probability of raining, so the in the long run, we've got 0.5556 probability of rain, because that in the long run. And just to note, it didn't actually matter what we put for our initial state here. We could have put 0, 1. Okay, because in the long run, it doesn't matter what you start, everything is going to level out. So that's it. We're done with Markov chain. No, we're done. See ya.